Good afternoon everyone. My name is Punima. I am explaining about Designer SJF scheduling program that automatically detects CPU bound and input output bound processes, process and justify an optimization technique to reduce starvation and evaluate its effectiveness with sample process sets. Introduction: an operating system acts as an intermediate between the computer hardware and user. Its its primary functions include managing resources like CPU, memory, and input-output device, and providing a stable and consistent environment for application to run. CPU scheduling is a core OS function that selects which process from the ready queue will be executed next by the CPU, aiming to optimize system performance based on criteria like throughput, turnaround time, and response time. The shortest job first non-primitive algorithm is one such scheduling strategy. The shortest job first non-processive scheduling algorithm executes the process with the smallest estimation CPU burst time from the ready queue to completion. A CPU based process spends most of the time doing computation, resulting in a few very long CPU bursts convert, resulting in a few very long CPU bursts converts. An input output bound process spends most of the time waiting for input output operation, resulting in many very short CPU bursts. Experimental setup: programming language used C. The provide C program is a full simulator includes and prints clear so you can experiment change burst arrival times and see how acting implementation effective starvation and averages automatically detect CPU bound versus input output bound process using each process recent burst history. Users a optimization to reduce starvation, prints a Gantt like timeline and pre-process matrices. Implementation step: the burst time is a list to handle process that alternate between CPU and input output. The detect type method implements get effective burst implements and agging optimization total CPU burst age agging rate. This is the key for sorting. Set up the current time ready queue and converts raw data into process object. Continuous until all processes are completed. Checks for processor whose arrival time is current time and moves them to the ready queue. The ready queue is sorted using a sample function, making the shortest effective job run first. The secondary key is arrival time. The selected process runs for first CPU burst, advancing current time. If the process is finished, it is completed. If the process has more burst, it is assumed to request input output. Flowchart: start, input, read process data for all processor, initialize, set current time is equal to 0, complete count is equal to 0, loop condition is completed, count greater than total processor, if S produced to step Y, if no end. Identify arrived jobs, checks the process where arrival time, current time and the process is not completed. CPU idle check: are there no arrival jobs? If S, CPU idle process increment time plus flow loop back to step 4. If no, proceed to next step. SJF selection: select the process from the arrival jobs with the minimum burst time. Execution: calculate P next start time is equal to current time, P next execute to completion, and calculate and display the average waiting time and average turnaround time. Code structure definition: this create a structure process with process ID like P1, P2, arrival time, burst time, completion time, waiting time, turnaround time. Next, taking input, user enters number of process, array stores all process details, then Your input PID arrival time and burst time for each process. Initially all processor are not completed. Initialize variables completed 0, no process finished at time. CPU time starts from t is equal to 0. Average wait and average DAT used later for averages. SJF scheduling loop run loop until all processor finish. Inside the loop find the process with minimum burst time that has already arrived. This finds the shortest available process. If no process has arrived at, CPU waits. Next, if a process is available, this calculates completion time is equal to time when the process finishes. Turnaround time CT minus AT, waiting time TAT minus VT, making process as completed. Next, after all process are completed, print result table. Prints of table of process ID, arrival time, burst time, completion time, waiting time, turnaround time, print averages, final summary. This program implements non-primitive shortest job first. At each moment it picks the current available process with minimum burst time, computes CTWT and TAT for each process, prints Gantt chart like sequence, finally calculate average waiting time and average turnaround time. Output, first enter number of processor 4, enter processor ID 1, time arrival 0, burst time 7, enter processor ID 2, arrival time 2, burst time 4, enter process ID 3, burst time 1, enter processor ID 4, arrival time 5, burst time 4. Gantt chart 1, 3, 2, 4, PID 1, 2, 3, 4. ID 1, average time 0, burst time 7, current time 7, waiting time 0, T87, PID 2, 82, BT2, and average waiting time 4, average turnaround time 8. Process execute after 64 seconds, return break. Observation, waiting time P1 is waiting time without agging would be. With agging, its maximum wait time before its first run is bounded. Turnaround time P1 starts at 0 and finishes at 2. Shortest jobs are still prioritized, but P1 is effective. Priority increases faster than without agging. Response time, the response time in CPU scheduling is a real metric that measures the responsiveness of a system, particularly in interactive or real-time environment. Number of context switches, it is used by the operating system to serve the state of currently running process and load the saved state of the next process to be run. 4 switches, P1 to P3, P3 to P2, PT to P4, P1, P3, P3, P2 and P2 to P4 and P4 to P1. CPU utilization, the CPU is the busy processing both input output bound and CPU bound jobs. Prioritizing and short input output bound comes to keep them responsive. Next, comparative evaluation, data used, data set, all arrival time and same time. Process P1, arrival time 0, burst time 6, P2, average time 0, burst time 2, P3, average time 0, burst time 8, P4, average time 0, burst time 3. Average weight is equal to 9.25. Average turnaround time is equal to 4.50 milliseconds. And comparison table, algorithm dataset 9.25, 4.50, content picture 0, remark high waiting time, data set to average average weight 8.0, average turnaround time 4.0, contents picture 0, remark moderate, data 3 7.0, average T80 3.5, context text 0, remark improved performance. Next, conclusion. In conclusion, the proposed SJF scheduling program successfully integrates automatic detection on CPU bound and input output bound process and applies priority tagging to effectively reduce activation by analyzing burst time and input output by analyzing burst time and input output weight each process and adapts its behavior to improve fairness while maintaining SJF's efficiency. The optimization technique dynamic tagging ensures that long CPU bound process eventually CPU time without significantly affecting the turnaround time of shorter tasks. Thank you.